Hey guys, so last time we talked about how there is a wealth of information within the frequencies of our neuro and bio waves that we are emanating on a daily basis, and how little we know about this, mainly because unfortunately, our existing body of knowledge and research and studies, they have not been covering this invisible part of human body and brain as much as we have studied the physical part. So for example, one of the things I talked about is that any study or research that you look at today, they're mainly about, when it comes to the brain, they're mainly about the physical brain and not so much about the brain waves, which is the invisible brain. In this video, I'll discuss how we could fill in that gap with some of our current technologies such as machine learning, artificial intelligence, when it comes to the gap in the body of knowledge of us understanding the depth of human brain waves and human cellular waves, and why that it's important. Because whether you're interested in these topics or not, you will be in the future affected by these, the marriage between the science and this technology, just because it's inevitable for us to connect the brain waves with the future of machines. The work that I started in 2013, 2012 basically touched upon the fact that in the future, the machines will become an extension of the human brain and human body. And so that's why, whether you're a developer, a designer, or just curious about these technologies because maybe you want to get into this field, these topics become very important. And because they're very abstract and they are quite early still, they need a little bit of an abstract thinking, and also from my end a bit of an abstract explaining. And so I'll do my best to categorize these topics so that they're a little bit a little bit less abstract, if you will, to follow, because it is such a futuristic sort of field. And also, we still don't know, there's just still so much that we don't know, that we need to sort of take everything with a grain of salt. And so that's why it becomes a little bit tricky to talk about these abstract phenomena. I do want to mention before I start that someone was mentioning and brought a great point in terms of the frequencies that I was talking about last time, in terms of the breaking of light and how, you know, we see and hear and all that great stuff. And that's exactly true. I'm not saying anything against that. In fact, I am using all of that knowledge and sort of taking it to the next step or next level, because the way in which we absorb information and interact within ourselves and with everybody else, it is through light and sound and those frequencies that we talked about. So definitely that's a great point. Now let's get into the part where we could potentially use the current technologies of machine learning, deep learning, AI, etc., to help understand these brain waves, because in the future we will be using them also, you know, in the technologies, in the brain and machine interfaces, which will also help us humanize the machines in the future, that I'll talk about more in the future. But it's important to understand the two different topics of discussions that we have here. One of them is that the fact that we're still don't understand the brain waves to its fullest. So that's where we could use, for example, deep learning to understand that. That's one part. Another part of the discussion is how then we could use these brain waves in the development of the future of machines, such as AGI or ASI, and make that an extension of the human brain and human body. And so if you can see the two differences, I think that's very important. So for the sake of this video, I'll be talking about the first portion, which is, okay, if we are going to use brain waves and cellular waves to design and develop future of AGI and ASI and these machines, how then can we actually use machine learning and deep learning to understand human brain waves at a deeper level than we have done today? Because the cognitive sciences and neurosciences, they are primarily focused on the physical aspect of the brain. In other words, while the cognitive sciences have failed us in terms of digging much deeper into understanding what type of information do all these brain waves and cellular waves actually carry, how does that information even translate, etc., because they have primarily been focusing on the physical brain and physical body. While that unfortunately has happened, there are ways in which we could use the current technology to expand on the current body of knowledge that we have when it comes to brain waves and cellular waves. And that is where this first category that I talked about comes in, because there is a way we could do that that will help us develop AGI ASI in the future. Also, to clarify and to not make anybody offended in terms of the great work that cognitive sciences have done, is that I'm not saying that there is no knowledge about brain waves and cellular waves. There are actually. But what I'm saying is that if you compare the current body of knowledge when it comes to understanding this invisible part of humanity, humans, as opposed to the visible part, which is the brain and the body, the comparison is just, you can't even compare, because the 95 plus whatever % of all this research studies that we've been doing, it's been all at the physical level. So we're still really in its infancy when it comes to the science of the brain waves and the science of the cellular waves. All we've done so far is that we've categorized them, and basically just within those categories we've been kind of happy with those 5 or 6 categories of brain waves. And when it comes to the cellular waves or the organ waves, we've also done some categorization, but that's about it. But if you compare those studies with the studies of the physical brain and the body brain, or the human body, it's just ridiculous. And so if we are going to use human waves, NeuroBio waves, in the future of the design and development of AGI, ASI, AI of the future, we do need to understand these waves much more deeper than we're doing today. And that is the part that I'm talking about today in terms of how we can do that. So one way in which we could use machine learning, deep learning, AI, etc., to help us understand this is to gather, analyze, and work on the brain waves data sets at a humongous data entry level. And because of that, discovering patterns. Once we discover those patterns, we could then have the machine learning, deep learning, AI also come up with results as to what they mean. Because when it comes to machine learning, deep learning, etc., it's all about gathering and collecting and feeding the machine as much as data as it's possible, then having the algorithms look for patterns. Based on those patterns, the machine teaches itself, gathers more data, teaches itself, evolves, etc. So it's like a you know, the way you already know how machine learning and deep learning works. And so, but the trick is, how do we do that? Because you do need to have certain knowledge about brain waves and these algorithms even before you start with something like that. And that is where the marriage between the science of brain waves and the technology of machine learning, deep learning comes in. That's where the marriage happens. But once you figure out that the way to categorize that data and write those algorithms, then we'll be able to use that massive amount of data and look for patterns, and then having the system, the codes, the algorithms actually then learn more and more and more about what the pattern is within all these brain waves that it's gathering. And it's actually not that hard to do. In the, I think 2 videos ago, I talk about how you can actually just use the data collected from brain waves in this case and just enter it as a CSV file. And a CSV file can very, very easily be loaded into a code that you've written, for example, in machine learning or deep learning, and then how to also look at how to categorize them. And then that way you'll be able to actually have a CSV file where then the algorithm just reads it and learns from it, and then it just evolves basically. We also talked about calibration last time, because when it comes to collecting brain waves, there's a lot of different differences in terms of different humans. But again, you actually you're able to address the reliability and of the data once you have enough of a number. So let's say that if you have 100 data points versus 100,000 data points, obviously in a machine learning and deep learning, once you have enough data collection within those CSV files from those brain waves, you'll be able to be much more confident in terms of what those data points actually mean, what those patterns mean when it comes to, for example, the state of a person. That's one thing I wanted to say. Another thing I wanted to say is that it's also very important, and that's where the marriage of brain sciences or brain wave sciences and these technologies, let's say machine learning, comes in. So there's a marriage there. Another way that the marriage works is that when you gather those data points from the brain waves, it's also important to not just categorize them as alpha, beta, gamma, etc., because we already kind of know about the differences in the brain frequencies and what that translates into when it comes to the state of a person. And that is where also the knowledge of cognitive sciences, of brain sciences, come in. And so one way to categorize that is in terms of those axes that I talked about when it comes to the deep thinking part of a person, which also was part of my dissertation. There are ways that we could look at the brain waves in terms of the frequency of it, exact frequency of it, in addition to the location of it, and then look at the 2 axes of the intensity of a thought versus the positivity versus the negativity of a thought that we talked about 2 videos ago, I think. And that's also another way that we could categorize these CSV files, because once we do that, then the machine, whatever algorithm that the algorithm that we've written will be able to then look for those patterns and read those patterns. So it's very tricky, and I know it's a little bit abstract. Sorry about that. I'm trying to like not make it abstract, but it is a little bit, because it's tricky in terms of how to actually make sure that the codes we've written in, let's say, Python in machine learning is able to detect those data that we're actually uploading with the CSV files within the algorithm, so that it doesn't, spit out the wrong pattern, if you will. So that's the only part that it's a little bit tricky, but we do have enough information to work around that. Once we're able to work around that, that is what I mean with when I said that we could then use, let's say, machine learning to go more in depth about the existing knowledge that we have when it comes to, let's say in this case, brainwaves. So I hope that makes sense. Basically, we could use the machine learning systems to help understand and deepen our existing body of knowledge when it comes to brainwaves, let's say, also cellular waves. Once we do that, then we're able to use that data to design and develop the future of AI machines, AGI and ASI, at a much deeper level, because we'll be able to understand it much deeper. To sum up, we can use the machines, in this case, let's say machine learning, to help us understand, in this case, let's say brainwaves, at a much deeper level through the algorithms and those CSV files that I talked about. Once we gather that information and understand it, then we could use that deeper knowledge in terms of brainwaves, and then use that in the design and development of the future of AI, in this case AGI and ASI, and have them be then the extension of the human brain, machines that are extension of the human body. So I hope this was helpful, and I hope I was able to discuss these abstract notions in a way that it was a little bit clearer than last time. Obviously, I'll post it on my LinkedIn, YouTube, IGTV, and also on my own domain. And then I'll dig deeper, and I continue with these videos. And yeah, if you have any question or comments, let me know. I hope that it makes sense, and I'm sure you guys have a ton of stuff to add. Definitely, this is an exploratory discussion for the future of these machines. So it's definitely nothing set in stone. It's just more or less food for thought. So thanks for listening. I'll talk to you next time. Bye.